Good evening, students. Welcome back. Today is the third day of this session and the last day of Module 1, that is Data Analytics. In today's session, we are going to step into one of the most important foundations of data analytics, that is statistics. You might be wondering, why statistics? Is it analyst about computers, coding, and big data tools? Well, the truth is, without statistics, data is just numbers. Statistics is what helps us make sense of it. Have you ever looked at your exam marks and thought, what's the average score of the class? Or wondered which student performed the best? Which is the below? Which one is the below average? That curiosity you had after the exams was actually statistics in action. Statistics is the science of collecting, analyzing, and interpreting data. In data analytics, it becomes the language through which data tells a story. So, we will begin this part 5, Introduction to Basic Statistics, that is, role of statistics in data analytics. We will see in coming slides Introduction, Basic Concepts of Statistics, Descriptive Statistics, Inferential Statistics, Role of Statistics in Data Analytics. Introduction. Why statistics? Statistics is the backbone of data analysis as it transforms raw numbers into actionable business insights. Instead of making decisions based on gut feelings, statistics helps us summarize data, spot patterns, and make predictions. It also helps in summarize large data sets quickly, that is, average, percentage, trends, to compare groups or categories. It also spot outliers or trends in user behavior. It also make predictions or recommendations. A significant constraint on realizing value from big data will be shortage of talent, particularly of people with deep expertise in statistics and machine learning, and the managers and analysts who know how to operate companies by using insights from big data. That is a word from McKinsey. Basic concepts of statistics. Definition. Statistics is like a toolkit we use to understand and make sense of information. It also helps us collect, organize, analyze, and interpret data to find patterns, trends, and relationships in the world around us. From analyzing scientific experiments to making informed businesses decisions, statistics plays an important role across many fields such as science, eco- economics, sorry, social sciences, engineering, and sports. Whether it's calculating the average test score in the classroom or predicting election outcomes based on a sample, statistics gives us tools to make data-driven decisions. We will see what does statistics actually help us to do. There are four main things which are as follows. Collect data. For example, a teacher collects marks of the students. Organize data, putting those marks into a table or chart. Analyze data, finding average, high marks, low marks, and patterns. Interpret data, drawing conclusions like the class did well overall, But question 3 was tough for the most of the students. This is called statistics. Types of statistics. There are commonly two types of statistics which are discussed below. Descriptive statistics. It helps us simplify and organize big chunks of data. This makes large amounts of data easier to understand. Inferential statistics. It is a little different. It uses smaller data to conclude a larger group. It helps us predict and draw conclusions about the population. As you can see in the picture, there are two types of statistics, that is descriptive statistics and inferential statistics. So to keep it simple, descriptive statistics meaning summarizing what we have. Inferential statistics meaning using a sample to predict or conclude about a larger group. Both are powerful and together they help us turn data into knowledge and decisions. Types of data statistics. Qualitative, that is categorical data, represents categories or labels. No numerical meaning. Examples: gender, male, female या other. Eye color, brown, blue, green. Department, HR, finance, marketing. Quantitative, that is numerical data, represents numeric values, can be measured or counted. Example: age 25 years, height 170 centimeter, number of products sold, that is 120. Scale of measurement. Nominal scale. Nominal variables can be placed into categories. These don't have a numerical value and so cannot be added, subtracted, divided, or multiplied. These also help know order, and nominal scale of measurement only satisfies the identity property of measurement. For example, gender is an example of a variable that is measured on a nominal scale. Individuals may be classified as male or female, but neither value represents more or less gender than the other. Ordinal scale. The ordinal scale contains things that you can place in order. It measures a variable in terms of magnitude or rank. Ordinal scales tell us relative order but give us no information regarding differences between the categories. The ordinal scale has the property of both identity and magnitude. For example, in a race, if Fram tails, uh, takes first and Vidar takes second place, we do not know competition was close by how many seconds. Interval scale. An interval scale has ordered numbers with meaningful divisions. The magnitude between the consecutive intervals are equal. Interval scales do not have a true zero. That is, in Celsius, 0 degrees does not mean the absence of heat. For example, temperature on Fahrenheit Celsius thermometer, example 90 degree, are the hotter than 45 degree, and the difference between 10 and 30 are the same as the difference between 60 degree and 80°. Ratio scale. The ratio scale of measurement is similar to the interval scale in that it has also represents quantity and has equality of units with one major differences. Zero is meaningful. No numbers exist below the zero. Ratio scales have all the characteristics of the nominal, ordinal, and interval scales. The simplest example of the ratio scale is the measurement of length. Having zero length or zero money means that there is no length and no money, but zero temperature is not an absolute zero. Population versus sample in statistics. As you can see in the picture, on the left side population is given and on the right side sample is given. From that population we have extracted some sample. A population refers to the entire set of individuals, objects or data points that you want to study. It can be a large or small depending on the scope of your research. For example, all students in a school or all people in a country. It provides a complete picture and is usually denoted by n. A sample is the subset of population that is selected for analysis. It used when studying the entire population is impractical or impossible. For example, if the population is all students in the school, a sample could be 50 students randomly chosen from different classes to participate in a survey. It offers an estimate and is denoted by small n. When to use population data? If the group you want to study is small or if complete data are readily available, collecting data from the entire population can eliminate sampling bias and provide accurate results. Studies that use population data examples are as follows. National census. Governments collect data from every citizen to obtain demographic information, allocate resources and plan services. Standardized academic testing. A school board may administer a standardized test to all students to assess overall performance or identify learning gaps. Quality control. For critical products like medical devices, every unit might be inspected to ensure safety and accuracy. Employee survey. In a smaller company, all employees might be surveyed to gauge employee satisfaction. Why to use sample data? If the group you want to study is large, geographically dispersed, or hard to reach, you might instead collect data from a representative sample. If your sample is chosen carefully, the associated data can be used to make accurate inferences about the population the sample result represents. Studies that use sample data examples are as follows. Public opinion polls. Rather than survey every citizen, posters collect data from a representative sample to estimate approval ratings or voting intentions. Marketing research. Companies collect sample data from their target demographic to understand preferences or predict product performance. Clinical trials. Researchers will test a new drug on a sample of patients to test its efficiency and safety. Em- Empirical research. Researchers across a broad range of fields that is psychology, ecology, sociology, often collect data from a sample to explore real-world phenomena. Population and sample formulas. The above one is population parameters, mean and standard deviation, and the second one is sample statistics, that is mean and standard deviation. If you find the population parameters, you have to find the value or you have to find the result from these formulas. And if you will find the sample statistics, you will find this, you will apply this formula and find the result. Students, you can take the snapshot of this uh, formula or write down somewhere. Population versus sample. Population. The population includes all members of a specified group. Sample. A sample is a subset of the population. Collecting data from an entire population can be time consuming, expensive, and sometimes impractical or impossible. Samples offer a more feasible approach to studying populations, allowing researchers to draw conclusions based on smaller, manageable datasets. In population includes all residents in the city, but in sample consists of thousand households, a subset of the entire population. Now the parameters of both population and the sample. Population parameter versus sample parameters statistics. Population parameter. It is a numerical characteristics that describes the entire population. Sample statistics. Statistics are calculated from sample data and serve as estimates or approximations of the corresponding population parameters. Parameters are typically unknown and must be estimated. In sample statistics, it calculated using data from a sample drawn from the population. Statistics are directly computed from sample data. In population parameter, calculated using data from a sample drawn from the population. Statistics are directly computed from sample data. And these sample statistics used to estimate population parameters based on the sample data. Statistics help researchers infer population characteristics from a representative subset of the population. Descriptive statistics. Now we will see what is descriptive statistics. Descriptive statistics is a branch of statistics that helps you summarize, organize, and present data in a meaningful and concise way. Its primary goal is to provide a clear summary of the datasets, main features, and characteristics. On the left side, you are seeing the figure raw data, and on the right side, you will see that figure descriptive statistics. It is clearly seen that white, orange, red, blue, silver, black, that is the color. Raw data that are extracted and in descriptive stats. It is clearly understood in the descriptive statistics. Now the components of descriptive statistics. What are the components of descriptive statistics? To get a comprehensive view of your data, descriptive statistics employs several key components. Measures of central tendency. These include the mean, median, and mode, which give you an idea of the average or typical value in your dataset. Measure or variability. These show how spread out your data is and include the range, variance, and standard deviation. Distribution shape. This looks at aspects like skewness and kudos to understand how your data is distributed. Graphical representations. Charts, graphs, and tables help you visualize your data. Common types include histograms, bar charts, pie charts, scatter plots, and box plots. Now, the importance of descriptive statistics. Descriptive statistics plays a crucial role in data analysis by providing basic information about variables in your dataset, highlighting potential relationships between variables, giving you a clear picture of what your current data shows. It's important to note that descriptive statistics only make statement about the data set you're analyzing. They don't go beyond your data or make projections. However, they don't provide a solid foundation for further statistical analysis and decision-making process. By using descriptive statistics, you can effectively summarize and communicate the key characteristics of your dataset, making it easier to understand patterns, trends, and distributions within your data. Types of descriptive statistics. Frequency distribution. A frequency distribution describes the number of observations for each possible value of a variable. It's the most primitive way, the most basic, hence this is all we will discuss about it in the article. To present a distribution, typically listening values from lowest to highest. As you can see in the figure, frequency distribution, the bar graph categorical data is given and the line graph, bar graph group numerical data and the frequency polygon. The graph is given. It's clearly seen the frequency distribution. You can display a frequency distribution using frequency tables, two-column table showing values and their frequencies, graph, pie chart, bar chart, and histograms. There are four types of frequency distributions: ungrouped frequency distribution, grouped frequency distribution, relative frequency distribution, and cumulative frequency distributions. Central tendency. Measure of central tendency help you find the middle or average of a dataset. The three most common measures are mode, the most frequent value in the dataset; median, the middle number in an ordered dataset; mean, the sum of all values divided by the total number of values. These measures attempt to describe what a typical data point might look like. The mean is the most commonly used measure of central tendency. Central tendency graph. This is a central tendency graph. In front of you, this is a central tendency graph. In this, you will see mode, median, and mean. Measure of central tendency. Mean. The mean, often referred to as the average, is the sum of all observations divided by the total number of observations. It represented by the formula that is given this, as you can see in the content. Please note it down or take the snapshot of this, where n is the number of observations and xi represents each individual value. For example, if you have salaries of 50,000, 55,000, and 60,000, the mean would be the salaries total, that is the addition, divided by 3, that is equal to 55,000. Median. The median is the middle value when your data is arranged in order. To find it, sort your data from lowest to highest. For an odd number of observations, select the middle number. For an even number, take the average of the two middle numbers. The median is the less effective by outliers than the mean, making it useful for skewed distributions. For instance, in income data, extremely high earners can significantly pull up the mean, while the median gives a better representation of a typical income. Mode. The mode is the value that appears most frequently in your dataset. A distribution can have an one mode, unimodal, two modes, bimodal, or multiple modes, multimodal. Some datasets may not have a mode at all. For example, in the set 2, 3, 3, 4, 5, 5, 5, 6, the mode is 5. The mode is particularly useful for categorical data where calculating a mean or median does not make sense. By using these measures of central tendency, you can gain valuable insights into the typical values of your data, helping you make more informed decisions in your statistical analysis. Variability. Variability refers to the spread of scores in a distribution. It helps you understand how spread out your data is from the central tendency. Common measures of variability include range, between the difference between the largest and the smallest values; interquartile range (IQR), the range of the middle 50% of scores; variance, the average squared differences of scores from the mean; standard deviation, the average amount by which scores differ from the mean. Variability. You can see in this picture the divergence of data from its mean value. These measures provide insights into the dispersion of your data, helping you make more informed decisions based on your dataset's characteristics. Range under the measure of variability. The range is the simplest measure of variability, calculated by subtracting the lowest value from the highest value in your dataset. It gives you a quick idea of how spread out your data is. For example, if you have a dataset of exam scores ranging from 65 to 98, the range would be 33 points. While easy to calculate, the range has limitations. It's sensitive to outliers and does not tell you much about the data is distributed between the streams. Variance. Variance digs deeper into your data spreads. It measures how far each number is the set in from the mean. The formula for variance is in front of you is given the formula for variance. You can take the snapshot or write down somewhere where lambda 2 is equal to variance x represents each value in the dataset. The mean is the mean and n is the number of values. A larger variance indicates that your data points are further from the mean and from each other. While variance provides valuable information, its squared units can be make interpretations challenging. Standard deviation. To address the interpretation issue of variance, you can use standard deviation. It's simply the square of root of the variance, bringing the measure back to your original units. The formula is in front of you given. Standard deviation tells you on average how far each value is from the mean. For example, if the mean height in a group is 170 centimeter with a standard deviation of 5 centimeter, you know the most heights fall within 5 centimeter above or below 170 centimeter. This measure is widely used in statistics and provides a reliable indicator of a spread. Interquartile range (IQR). The IQR focuses on the middle 50% of your data, making it resident to outliers. To calculate the IQR, you first need to find the first quintile Q1, 25th percentile, and the third quintile Q3, 75 percentile. IQL is then calculated as IQR is equal to Q3 minus Q1. This measure is particularly useful for skewed distributions where the mean and standard deviation might be misleading. It's often used in box plots to visualize data spread. By using these measures of variability, you can gain a comprehensive understanding of how your data is distributed, helping you make more informed decisions in your statistical analysis. Now, the application of descriptive statistics, business and finance. In the world of business and finance, descriptive statistics are invaluable for decision making. You can use them to analyze financial information to make informed decisions, monitor relationship between variables using scatter plots, summarize and communicate key characteristics of a financial data set. Healthcare and medicine. In healthcare and medicine, descriptive statistics helps you summarize patient data, analyze test score and survey results, present findings visually using histograms, pie chart, and scattered plots. For example, you might use descriptive statistics to examine the distribution of patient ages in a study or to analyze the effectiveness of a new treatment by comparing mean outcome between groups. In education sector, educators rely on descriptive statistics to make sense of test score and performance data, identify areas where students excel or struggle, tailor educational statistics to meet learners' needs. You can use measures of central tendency, that is mean median mode, to understand average student performance, and measures of variability, that is fringe standard and deviation, to assess the consistency of scores across a class. Social sciences. In social sciences, descriptive statistics helps you to summarize survey results, analyze demographic data, identify patterns and trends in social phenomena. For instance, you might use frequency distribution to examine the age distribution in a population study or calculate percentile to understand income distribution in a Socioeconomic analysis. By applying descriptive statistics across these fields, you can transform raw data into meaningful information, enabling better decision making and deeper insights into complex phenomena. Inferential statistics. Inferential statistics is an important tool that allows us to make predictions and conclusions about a population based on sample data. Unlike descriptive statistics, which only summarize data, inferential statistics let us test hypotheses, make estimates, and measure the uncertainty about our predictions. These tools are essential for evaluating models, testing assumptions, and supporting data-driven decision making. For example, instead of surveying every voter in a country, we can survey a few thousands and still make reliable conclusions about the entire population's opinion. Inferential statistics provides the tools to do this systematically and mathematically. Why do we need inferential statistics? In real-world scenarios, analyzing an entire population is often impossible. Instead, we collect data from a sample and use inferential statistics to conclude the whole population, test claims or hypotheses, calculate confidence intervals and p-values to measure uncertainty, make predictions with statistical models. Now the working of inferential statistics. Inferential statistics involves drawing conclusions or making inferences about a population based on data collected from a sample of that population. Sorry. How it works. Sampling. You start by collecting data from a subset of the population you are interested in studying. This subset is called a sample. Analysis. After collecting data, you use various statistical techniques. This might include calculating measures like means, median, standard deviation, correlations, or regression coefficients. Inference. Once you have analyzed that sample data, you make inferences or generalizations about the population from which the sample was drawn. These inferences are based on the assumption that the sample is representative of the population. Inferential statistics includes hypothesis testing, confidence intervals, and regression analysis, among other techniques. These methods help researchers determine whether their findings are statistically significant and whether they can generalize their results to the larger population. Types of inferential statistics. Hypothesis testing. Hypothesis testing is a fundamental technique in inferential statistics. It involves testing a hypothesis about a population parameter, such as a mean or proportion, using sample data. The process typically involves setting up null and alternative hypotheses and conducting a statistical test to determine whether there is enough evidence to reject the null hypothesis in favor of the alternative hypothesis. Example: a researcher might hypothesize that the average income of a people in a certain city is greater than $50,000 per year. They would collect a sample of incomes, conduct a hypothesis test, and determine whether the data provide enough evidence to support or reject this hypothesis. Z-test. The Z-test is a statistical test to determine whether the mean of two populations differ from when the population variance is known and the sample size is large. Typically, n is greater than 30. It's based on the standard normal deviation Z distribution. The Z-test statistic follows a standard nominal distribution under the null hypothesis. Example: a researcher wants to determine if the mean height of a population is significantly different from 65 inches. They collect a large sample of heights with a known population standard deviation and use the Z-test to compare the sample mean of the population mean. T-test. The t-test is used when the population standard deviation is unknown or the sample size is small, typically n is less than 30. Is based on the student's t-distribution, which has thicker tails than the standard normal distribution. There are two main types of t-test: the independent samples t-test and the paired sample t-test. The formula for t-test statistics is similar to the z-test, but it uses the sample standard deviation instead of population standard deviation. Example: a researcher wants to determine if there is a significant difference in exam scores between two groups of students. They collect exam scores from each group and use the t-test to compare the means. F-test. The F-test is used to compare the variances of two populations or more than two populations. It's commonly used in the analysis of the variance (ANOVA) to test the differences among means of multiple groups. The F-test statistic follows an F distribution which is positively skewed and takes on only non-negative values. In ANOVA, the F-test compares the variance between groups to the variance within groups. If the ratio of these variances is sufficiently large, it suggests that the group's mean are different. Example: a researcher wants to determine if there are differences in the effectiveness of three teaching methods on student performance. They collect performance data from students taught using each method and use ANOVA, which utilize the F-test to compare the variances between and within the groups. Confidence intervals. Confidence intervals provides a large range of values within which a population parameters is likely to lie and a level of confidence associated with that range. They are often used to estimate the true value of the population parameter based on the sample data. The width of the confidence interval depends on the sample size and desired level of confidence. The example of this: a pollster might use a confidence interval to estimate the proportion of voters who support a particular candidate. The confidence interval would give a range of values within which the true proportion of supporters is likely to lie, along with a confidence level such as 95%. Regression analysis. Regression analysis examines the relationship between one or more independent variables and a dependent variable. It can be used to predict the dependent variable's value based on the independent variables values. Regression analysis also allows for testing hypotheses about the strength and direction of the relationship between the variables. Example, a researcher might use regression analysis to examine the relationship between hours of study and exam scores. They could then use the regression model to predict exam scores based on the hours studied. Analysis of variance ANOVA. ANOVA is a statistical technique that compares mean across two or more groups. It tests whether there are statistically significant differences between the groups. Means ANOVA calculates both within group variance and between group variance to determine whether any observed differences are likely due to chance or represent true differences between groups. Example, a researcher might use ANOVA to compare the effectiveness of three different teaching methods on student performance. They would collect data on student performance in each group and use ANOVA to determine whether there are significant differences in performance between their groups. Chi-square test. Chi-square tests are used to determine whether there is a significant association between two categorical variables. They compare the observed frequency distribution of the data to the expected frequency distribution under the null hypothesis of independence between the variables. A researcher might use a chi-square test to examine whether there is a significant relationship between gender and voting preferences. They would collect data on the gender and voting preferences of a sample of voters and use a chi-square test to determine whether gender and voting preferences are independent. This is the example of chi-square test. How analysts use inferential statistics in decision making. Drawing conclusions from sample data. Analysts often have access to only a subset of data, that is, sample, rather than the entire population. Inferential statistics allow them to calculate the population based on this sample data. For example, a marketing analyst might conduct surveys on a sample of customers to infer the preferences or behaviors of the entire customer base. Hypothesis testing for decision making. Hypothesis testing helps analysts make decisions by providing a structured framework for evaluating hypotheses or claims about populations. For instance, a business analyst might use hypothesis testing to determine whether implementing a new marketing strategy significantly impacts sales. Risk assessment and management. Inferential statistics helps assess and manage risk by quantifying uncertainty. Analysts can use techniques such as confidence intervals to estimate the range of possible outcomes and make decisions accordingly. In finance, for example, analysts might use inferential statistics to assess the risk associated with investment portfolios. Predictive modeling and forecasting. Analysts often use inferential statistics to build predictive models and forecast future events or outcomes. Regression analysis, for instance, is commonly used to predict sales figures based on historical data, allowing businesses to make informed decisions about inventory management and resource allocation. Experimental design and optimization. Inferential statistics are crucial in experimental design and optimization process. By conducting controlled experiments and analyzing data using techniques like analysis of variance, ANOVA, analysts can identify factors that significantly impact outcomes and optimize process or products accordingly. Policy evaluation and decision support. In fields such as public policy and healthcare, inferential statistics are used to evaluate the effectiveness of interventions or policies. Analysts can assess whether a policy has achieved its intended goals and provide evidence based recommendations for decision makers by comparing outcomes between treatment and control groups. Policy evaluation and decision support. In fields such as public policy and healthcare, functional statistics are used to evaluate the effectiveness of interventions or policies. Analysts can assess whether a policy has achieved its intended goals and provide evidence-based recommendations for decision makers by comparing outcomes between treatment and control groups. This point is very important. That is why I repeat this point. Quality control and process improvement. Inferential statistics are used for quality control and process improvement in manufacturing and operations management. Control charts and hypothesis testing help analysts identify deviations from expected performance and make data-driven decisions to enhance product quality and efficiency. Inferential statistics example. Evaluating a new delivery algorithm using inferential statistics. A quick commerce company wants to check a new delivery algorithms reduces delivery times compared to the current system. Experiment setup. 100 orders split into two groups, 50 with the new algorithm, 50 with the current system. Delivery times for both groups are recorded. This is the comparison. This is the evaluating a new delivery algorithm using inferential statistics. That is the steps. Steps are given. Hypothesis, significant level, test statistic, perform a t-test or z-test. You can write down or you can take the snapshot of this comparison. If you need to compare, if you need to evaluate a new delivery algorithm using inferential statistics, you have to use this comparison. You have to do this experiment also. Alternative analysis, confidential, interval, these all the experiment you have to do. Role of statistics in data analyst. What is the role of data analyst and analytics for statistics? Statistics is equal to the backbone of data analyst. Statistics, that is summarization, inference, prediction, and decision making. This combines the role of statistics in data analyst. So before we conclude this uh, part 5 module, descriptive stats is like looking at a photo of your data set. while inferential stats is like predicting what the entire photo album might look like based on just a few photos. It also gives us the power of generalize, predict, and make data driven decisions with confidence. Now, moving forward, Part 6, Introduction to Business Analyst and Power BI. Now, in this lecture, uh, in coming slides, we will see Introduction to Business Analyst, components of business analyst, applications of business analytics, steps in analytics process, role of statistics in BA, what is Power BI, key features of Power BI ecosystem, role of Power BI in business analyst, analyst. Now moving forward, introduction to business and analytics. Business analytics involves turning raw data into actionable insights. Basically, it's the method involved with utilization data to tackle business issues and further develop results. It involves examining past and current data to find trends, patterns, and opportunities that can influence strategic planning and performance improvement across all levels. Components of business analytics are data storage. The data is stored by the computers in a way that it can be further used in the future. The processing of this data using storage devices is known as data storage. Object storage, block storage, etc. are some of the storage products and services. Data visualization. It is a process of graphically representing the information or insights drawn through the analysis of data. Data visualization makes the communication of outputs to management easier in simple terms. Insights. Insights are the outputs and inferences drawn from the analysis of data by implementing business analytics techniques and tools. Data security. One of the most important components of business analytics is data security. It involves monitoring and identifying malicious activities in the security network. Real-time data and predictive modeling techniques are used to identify vulnerabilities in the system. The business analytics process, step by step, is guide. Business problem framing, that is identify the business problem to be solved. Now it goes step 2, analytics problem framing, that is identify metrics and specific points to analyze. Step 3, data, obtain and clean data from multiple sources. Step 5, deployment, test the solution in real time and decide the optimum strategy. Step 6, sorry, it is written in step 6, methodology selection and model building. Select method and crucial metrics, build custom models if required. So these are the 5-step guide for the analytics process. Step by step is given in front of you. These are the 5 important steps which is used in the business analytics process. Application of business analytics. Applications of business analytics. Price point comparison, optimization of supply chains, forecasting revenue, finding out the number of cabs required in a region, recommendation steps, fraud detection, pinpointing reasons for employee attrition. These are the application of business analytics. Now what we face the challenges of business analytics are as follows. Data complexity. With data from various systems and resources, understanding connectivity and ensuring quality is significantly difficult. Much effort is needed to ensure accuracy and content. Data interpretation. Even with quality data, finding meaningful insights require considerable data science and analytical expertise to explore relationships and patterns effectively. Tool disconnectivity. Many analytics tools and platforms generate output data is often disconnected rather than integrated, hindering enterprises wide awareness. Acceptance hesitation. Lack of skills and a data driven culture can make organizational alignment and implementation of analytics methodologies slow. Despite extensive proof of concept, patience and persistence thus become mandatory. Sorry. Role of statistics in business analytics. Understanding descriptive statistics in business analytics. This branch of statistics focus on presenting quantitative descriptions in a manageable form, allowing business to understand their data at a glance. For example, a company analyzing sales data might calculate the average sales per month to gauge over performance. By summarizing this information, business can quickly identify trends and anomalies that warrant further investigation. Moreover, descriptive statistics often employ visual tools such as charts and graphs to enhance comparison. The importance of inferential statistics in business decision making is while descriptive statistics provide a snapshot of data, inferential statistics allow business to make predictions and generalizations about a larger population based on sample data. This branch of statistics is crucial for decision-making processes where it is inferential or impossible to collect data from the entire population. For instance, a company may conduct a survey of 1,000 customers to infer preferences about a new product line that will ultimately be marked to millions. Using regression analysis in business analytics. Regression analysis is a powerful statistical tool used in business analytics to understand relationships between variables and predict outcomes. By modeling the relationship between a dependent variable and one or more independent variables, business can gain insights into how changes in one factor may influence another. For instance, a company might use regression analysis to determine how advertising spend impacts sales revenue. By establishing this relationship quantitatively, business can make informed decisions about budget allocation for marketing efforts. There are various types of analysis including linear regression, multiple regression, and logistics regression, each serving different analytical needs. A practical example can be seen in e-commerce platforms that analyze customer behavior. By applying regression analysis to historical purchase data, they can predict future buying patterns and tailors marketing strategies accordingly. These predictive capabilities not only enhance customer engagement but also optimize resources allocation. The role of probability in business and analytics. Understanding probability allows business to access likelihood of various outcomes based on historical data and current trends. For example, a financial institution might use probability models to evaluate the risk associated with loan approvals by analyzing the likelihood of default based on borrower characteristics. Utilization hypothesis testing in business decision making. Hypothesis testing is a fundamental aspect of inferential statistics that allows business to make decisions based on sample data. For example, a company may want to test whether a new marketing strategy leads into increased sales compared to its previous approach. By collecting sales data before and after implementing the new strategy, analysts can perform hypothesis testing to assess whether any observed changes are statistically significant or merely due to random variation. The results of such tests provide valuable insights that guide strategic decisions, whether to continue with the new strategy or relevant to the old one, ultimately impacting the company's bottom line. Incorporating data visualization in business analytics. Data visualization plays an essential role in business analytics by transforming complex datasets into intuitive visual formats that facilitate understanding and interpretation. Effective visualization techniques such as charts, graphs, heat maps, and dashboards allow stakeholders to quickly grasp key insights without delving into raw data. For instance, a company might use pie charts to illustrate market share distribution among competitors or line chart to track performance metrics over time. The future of statistics in business analytics. The future of business analytics will see statistics evolving with advancement in technology, AI and machine learning, enabling deeper predictive insights from complex large scale data. As organizations increasingly rely on data driven strategies, the need for professionals' skills in both analytics and applied statistics will grow, making statistical expertise essential for informed decisions and long term business success. Now, some important roles in business analytics: designation and right side description. Business analyst developing visualizations, building APIs, and creating and working with dashboards. Data analyst analyzing data trends and finding valuable insights and matrices. Decision analyst analytics professional working with data and client requirements to find out the optimum path for a solution and its implementation. Business consultant, working with partner clients from planning to implementation phases. These are the some important roles in business analytics. Now the powerful tool that is called Power, Power BI. What is Power BI? Power BI is a software developed by Microsoft that helps you to turn raw data into clear and useful information. It helps to create interactive charts, reports, and dashboards so you can easily understand your data. Whether you work in business, research, or any field that uses data, Power BI makes it easier to find patterns, spot trends, and make better decisions. As you see in the picture, Power Query Editor goes to model relationships plus day or the per day and goes to visualization. This is the power of Power BI. Why to use Power BI? Why Power BI is useful? Data visualization. It turns complex data into clear and simple charts, graphs, and dashboards. This makes it easy to quickly spot trends and patterns in our data. That is why it is important. And many ways in the following, there are many ways why it is important, why it is used. Improve decision making. It helps us to create reports that highlights most important areas. All the key information is in one place, so you can quickly make decisions based on data. Real-time data analysis. By using it, we can keep track of our data in real time and set up live dashboards to monitor how things are going. This is used in sales, operations, or customer support who need to respond changes quickly. Easy access to data from multiple sources. It allows us to connect to various data sources like Excel, SQL databases, and cloud services such as Google Analytics or Salesforce. User-friendly interface. We can just drag and drop out our data into charts and graphs with no coding required. Also, it offers templates and visual to help us get started quickly even if we are new to data analysis. The key components of Power BI are Power BI desktops, Power BI services, Power BI mobile, Power BI gateways, Power BI data visualization. These are the key components of Power BI. Step by step guide to use for Power BI. Working of Power BI. What are the working process of Power BI? Download Power BI desktop. Second, connect to data. Third, data cleaning and transformation. Fourth, create visualization. Fifth, build a dashboard. And last, sixth, share your work. This is the working process of Power BI with Power BI. Key features of Power BI. Data connection. Microsoft has developed data source connections with a huge list of sources like SQL, Azure, Excel, text, CSV, PDF, cloud, and non and on-premises data. It does not matter where the data is and what format it is. We will get a detailed view of it. In the picture, you are seeing the get data, the formats, And in lower picture, you will see the city names, manager table, sales table, city table. This is a relationship table. Data relationships. In Power BI, if you have data in multiple columns, then we can define the relationship between those tables based on the at least one matching column from either table. Below is the screenshot of creating relationship between tables. We call this process data modeling in Power BI. This table is data modeling. Power Query, Power Pivot Access. We can edit the data in Power BI using Power Query in Excel and Power Pivot. These are all different components of Power BI, which helps the user alter the data to fit their needs. Power BI query is used for data transformation and manipulation tools, and Power Pivot is a memory tool to model the data. Cost of Power BI. We would consider Power BI cost a key feature because when you compare Power BI with other data visualization tools like Tableau, QuickLike View, and other products cost much less than that. And one more thing about Power BI is its free version of Power BI Desktop comes free of cost with enough features for the starter to get started with data visualization. Custom visualizations. Power BI has many built-in visuals to build dashboards and reports. Apart from these built-in visuals, user can download the custom visual from marketplaces per their requirements. Power BI question and answers. Power BI can answer your queries regarding the uploaded data. For example, after the data is uploaded to Power BI, it would help you with the information required like what are the total sales for the year 2018. You have to type the question. Then it would show the result with a beautiful visual or chart. Report sharing. When you share a report in Excel, you share it with the data sets. But in Power BI using Power BI Pro services, we can share the report with team members without worrying about data security. That is the power of Power BI. Mobile app. The Power BI app is available to download in Google Play Store. It, it makes the report reaching the end users much easier and simpler. Once the report is shared with the end user, they must sit in the front of the laptop or system. Rather, they can open the Power BI app on their mobile and start reading the report instantly. Other features of Power BI are a quick share of reports to colleagues or other through Power BI services, real-time analytics, representation of the data through rich visuals and graphics. It has control over end users' activities. Simple drag and drop method to create visualizations and dashboards. An easy way of data import and export options are there. Auto refresh of data in case of a cloud-based data source. Interactive dashboard with slicers and filters. Easy installation procedures. DAX functions to create calculated measures. Using Power BI published to the web, we can publish the story on our organization's website with stunning visualizations. Now, what is Power BI ecosystem? The Power BI ecosystem is Microsoft comprehensive business analytics platform designed to transfer raw data into actionable insights through integrated tools and services. It enables users across various roles, from business users to report creators and developers, to connect, visualize, and share data seamlessly across organizations. Power BI ecosystem core components: Power BI Desktop, a free Windows applications for data preparation, modeling, and report creation. It supports 100 plus data sources, example Excel, SQL, cloud services, etc. Includes Power Query Editor for data transformation and allows building interactive visualizations and complex data models using DAX, that is, data analysis expressions. Power BI service, a cloud-based SaaS platform for publishing, sharing, and collaborating on reports. You can get this SaaS platform in this website, awpapp.powerbi.com. You can write it down. The key features include workspaces for team collaboration and apps for distributing content, scheduled data refreshers, AI-powered insights, example quick insights, natural language question and answers, and integration with Microsoft tools like Teams and SharePoint. Security measures like role-based access control (RLS), encryption and sensitivity labels. Power BI Mobile apps for iOS, Android, and Windows devices to access reports and dashboards on the go. Features include real-time data access, offline viewing, push notifications, anno- annotations, and customization interfaces. Integration with Microsoft Fabric. Power BI is a core workload within Microsoft Fabric, an all-in-one analytics platform. Key integrations include OneLake, a unified data lake allowing direct querying without data import, direct lake mode, shared compatibilities like data flows, data preparation, security via Microsoft Purview, and Copilot, AI access, AI assisted insights. No migration is needed for exciting existing Power BI content, and Fabric adds advanced features while maintaining familiarity. Usage scenarios. Power BI supports diverse implementation patterns, content collaboration and delivery, personal BI, individual analysis using personal workspaces, team departmental BI, collaboration via workspace and apps, enterprise BI, large scale distribution using premium fabric capacities, self service Power BI, manage self services, reusing shared semantic models for report creation, data preparation, centralizing ETL processes with data flows, real-time analytics, building real-time dashboards, embedding and hybrid, embedding reports in custom applications for internal or external users. On-premises reporting via Power BI report server. Advanced tool and capabilities. Pagnitin reported pixel perfect printable reports created with Power BI report builder. Development tools. Support for APIs, Azure DevOps integration, and third-party tools like Tabular Editor for advanced data model management. AI integration. Features like key influencer, anomaly detection, and Python are scripting for advanced analytics. Getting started. How to get started for Power BI. Step-by-step workflow. Connect to data sources in Power BI desktop. Then transform and model data using Power BI query. Create interactive reports and visualizations. Publish to Power BI services for sharing and collaboration. Licensing. Options include free license for consumers and premium Fabric capabilities, FSQs for enterprise features. Role of Power BI in business analytics. What are the role of Power BI in business analytics? Are as follows. Data integration. Connects to a wide variety of data sources. It also provides a unified view of business data rows, departments, data preparation and transformation. Use Power Query for cleaning and shaping data. Ensure consistency and accuracy in analytics. Data modeling and analysis. DAX, data analysis expressions, enables advanced calculations and KPIs. Visualizations and reporting, supports custom visuals tailored to business needs, and many more. The Power BI role is many more. Here is some real-time insights. It connects to live data sources for up-to-date dashboards, collaboration and decision making. Reports and dashboards can be shared across arrives via Power BI services, AI and predictive analytics, built-in AI and ML capabilities for trained access by role, natural language question and answer allows users to ask questions. Alright everyone, with that we come to the end of today's session of our value-added course on data analytics. We started with an overview of data analytics and saw how it's shaping business and decision making everywhere. We explored the role of statistics in data analytics, understanding descriptive versus inferential statistics, and how they help us summarize and predict. We also stepped into the world of business analytics, its process, and real-time applications. Finally, we learned about Power BI. It's a powerful tool, what it is, its ecosystem, and how it works step by step to turn raw data into powerful insights. I want to remember this. I want to remember you this. Data by itself is just numbers. It's analytics, the process of cleaning, analyzing, and visualizing that gives those numbers meaning and turns them into decisions. Thank you all for your active participation today. I hope this session has sparked your curiosity and helped you see how exciting and impactful data analytics can be. In the upcoming modules, you will get more hands on practice and see these concepts in action. Till then, keep exploring, keep questioning, and remember every dataset has a story waiting to be told. It's up to us to discover it. These are the references which you will get the information. If we get the data, you can take the snapshot of this. Thank you all for your patient listening. Thank you all. Any question you may ask now? Any doubts, any questions you may ask now?